Well, and after interruption, we continue designing of airplane. And at the beginning, as usually, I count pronouncing the number of class. It's class number 6. It's practical class number 6, and it's the third class of designing of airplane. And now we about to start designing the fuselage, people, and that is real disaster will be. No, first, before we get started immediately to work with the fuselage, what we did, analyzed statistical data and have got so-called relative masses of different technical systems of airplane. Knowing the absolute value of payload and understanding what is portion relative mass of payload inside of this airplane, we able to calculate the awaitable mass of the whole airplane, takeoff mass. Next, understanding the balance of forces acting to the airplane, we insist that weight of airplane equal to the lift, and lift determines the wing area. After this, we have calculated the wing area. Do not repeat how we did it. Video number 2, video number 1, video number 2. It was explained. After we know the wing area and analyzing statistical data for dimensionless coefficients like wing aspect ratio, wing narrowing, relative wing narrowing, and other parameters that may be useful for you, for stabilizer, for fin, and so on, knowing these dimensionless parameters for your class of airplane, the airplanes that you consider as statistical data for you, and having wing area, we may determine first the span of the wing and next the chord of the wing. So these two important geometrical parameters of the wing we already approximately know. Why I say approximately? Because I already explained it to you. Whatever we do while airplane designing, it passes through some stages, and in each stage it's changed in some range. No, there is no another way to do it, at least now, last 100 of years. And after you determine parameters of the wing, selecting the balancing scheme, in our case, it will be conventional. I hope everyone understands. We don't need to complicate something. So for us, it will be conventional scheme with stabilizer behind of the wing. Question is whether it's low wing or high wing, up to you. And watching your examples, please, your prototype airplanes. Next, it's necessary to decide where to place stabilizer on height of the along height, let's say, along the height of the airplane with respect to the wing by height. Next, it's necessary to decide what is the area of stabilizer, and of course, it decides on one hand on the area of wing, on other hand, it depends on how far stabilizer from the wing actually. What is the arm of stabilizer? What is the arm of force that counteracting to the wing lift? Of course, for this it's necessary first, at least to determine fuselage, length, fuselage, and so on. It's too much difficult for you, maybe yet. And I have proposed, I gave you advice, do consider that areas of stabilizer and fin are around 20% of wing area, just to simplify your task. But to be frank, all the students of our faculty, year by year, pass through the same task. And 35 years ago, I also did this task, but we did it even in the more detailed way. We did it more. So if everyone before you have stand it, I trust you also able to stand it. Let's continue. Fuselage. First, I have decided finally, during this interruption, during this pause, I have decided that everyone will do passenger plane, because to explain additionally how to plan, how to compose the cargo plane cabin. Actually, you understand, maybe it depends not on the weight of payload in this case, it depends on overall sizes of cargoes that you're going to no to take inside, whether it will be just some pallets, let's say, with cargoes, or it will be some transport, some vehicles like military vehicles, for instance, or you design this airplane, for instance, for transporting of another airplanes or their pieces, and so on, depending on the purpose of this cargo airplane and depending on their what type of cargo it should transport. Let's imagine that we're talking only about passenger airplane. And to pay attention here, layout cross-section of the fuselage for different airplanes. You see the names of the airplane and what they differ with. Their cross-sections, you see, circular, elliptical in horizontal line plane, elliptical or some bulb, let's say, in vertical plane, uh, created by some circles or by some bulbs, depends on. They depends on how many seats you place in line, in one row, as it's called, and how many aisles you do, spaces between these lines of seats. Of course, quite clear that for people it's more convenient when they're sitting by couples, not by quadras and not by fifths, as you might see here is in Boeing. Of course, it comes about economy class of Boeing. Five seats together in one group. Plus to this, fuselage may be single-decked and double-decked. We will see it later. And the worst of all this story that all these distances for three different classes they are regulated with international norms, and it's necessary to follow to these norms if you're going to use your airplane not only inside of I don't know, inside of your village, for instance, but you are going to fly somewhere abroad. And do pay attention what you need to do. You need to decide what will be the diameter of your fuselage, what will be this composition inside of your fuselage. Again, please, if I were you, follow the prototype. If prototype recommend 4 seats, okay, let it be 4 seats in line. If in prototype they used 6 seats in line in one row, do use 6 seats in line. No, seriously, it's up to you. And next, it's necessary to count how many rows, how many lines of seats you have. It's also obvious how to do it, but it's not the whole truth. To seats, I will come back right now, but do pay attention what we see in cross section also. Here is for double decker, for instance. It's colorful, so it's visible. Under the deck, under the passenger floor, there is a space that should be used for what? No, at least for passenger luggage, for accommodating for placing the passenger luggage. It's also usually fulfilled according to sizes of those so-called pallets, something like boxes, special boxes which luggage is placed into, and next the whole such a box placed inside of the fuselage under the floor. Well, sorry, a bit jumping. Together with the slides, I will show you, maybe I even should do it before start explanation, a couple of places where you may refer to. First, the most simplified place. Once again, remind you, book of Hai, textbook of Hai, author is Fedotov Mikhail Nikolaevich. And in his book, let's see, content, wings we might find 27 and fuselage 144 as far as I remember. 27. No, first, of course, it will be an explanation of the most general things about wings. Here is, do pay attention, in the first picture. It's already explained some parameters of the wing like span, chord, area, and so on, and angle of sweepness in case you use a swept wing. And additionally, it's explained next what we understood as wing aspect ratio. As I said, in our literature, usually it's designated with big lambda. Do pay attention that, no, what I've been laughing about before, that in all the English talking books and in our literature, the these litteras that use for span, chord, whatsoever, they may appear different. They do not coincide. So be attentive. Compulsory reading something or using something. Compulsory refer to the scheme that comes to this place in order not to make mistakes. That is wing aspect ratio, as you see, and wing taper ratio also, the relative narrowing of the wing. And next, it's explained how to find quite the same picture, but already in high textbook, as we have seen, quite the same picture. How to find the value and the place of mean aerodynamical chord. No, once again, in English books, it may be called just mean chord. Well, this mean chord and how to find it for tapered wing using this parameter of wing taper ratio, wing ratio of narrowing, let's say. Very well. No, and whatever you need there, it's possible to find. Some short knowledge and fuselage. Fuselage 144. Let me to show you. Cross sections, outer shapes of fuselage vary. Vary from rectangular to the circular, oval, and some compound complex created by some shapes. Take a look what it may be when we're talking about the inner interior, what it looks like. Cargo, cargo combined with passenger, passenger, double decker, three decker. By the word, last version of Boeing, it's three decker. They have no 2.5 decker, let's say. In that bulb on their nose, they already arranged third deck in the last version of Boeing 747, 747-8. And some parameters of fuselage. Also, you see something like elongation of fuselage, but now it's designated lambda f, which show the length to diameter. Whether it's useful for you, not useful for you. No, in this project, I afraid it's not much useful, these parameters for you, so I'm not even going to explain it. And next, once again, what we need to do. Oh, I forgot to show you a couple of more another sources. Have found, no, before class, have found some things for you. Maybe again, it's too much of information, but because I was said that you can't use some links in internet, no, like officially you're forbidden to use it. And I was proposed to send you files if I consider something useful for you. No, that is why you see I practically bombing you either with books or with video additionally to classes. Maybe somewhere they will be useful for you if you save it. Once again, people, you see different layouts of the same airplane. Pay attention, it's the same airplane, three different cabin designs of Airbus 380. And certainly it's visible for us that it's quite different amount of people will be inside. No, you may compare the distance between rows here and, for instance, in this place. Or here is visible economy class or business class and something quite different. You see, it's first class, and completely packed with economy class seats. No, you understand. Depending on how you design inner layout, it will be either different lenses of the fuselage. No, if you already have some model of airplane quite clear, it's not possible. Quite clear that it will be inside of the same diameter. You will have inside of the same size, external size of the fuselage, you will have some different layout of interior, let's say, and depending on this, you will have different payload inside the airplane. No, and due to this, you may vary the distance of the flight. If you have less people, less payload on board, it means that you may increase the relative weight of fuel. And relative weight of fuel, it means that you may afford to fly far without additional landing somewhere for refueling. No, I hope you already understand those things very well. Up to you whether you will use norms of economy class or business class, or the airplane will be exclusively for first class. Up to you. If I were you, I would divide like 30 to 70, for instance, like business class and economy class. If it's you consider that it's difficult, do completely everything for economy class. No, what you see in cross section, да, the economy. No, here is book in English, but some pictures, as they took these pictures in Airbus, some pictures they are in German language. And do pay attention, here is where we have 6 seats, it's economy class, 5 seats, it's business class, and distances different between seats, you see, this so-called isle, and first class. No, and in scheme, it's also very well visible where we have which class. That one, I hope you understood. So passenger cabin approximately may be designed by calculating how many seats in line in row and how many rows you need and what is the distance between these rows. What is the distance between rows? Let's come back to the place. Also, it's not a book. I should say it's not a book. It's it's something like presentation of, you see, Federal Aviation Administration. I will show you right now our slides again. I hope it will be enough for you information of slides. I'm just why I show you this in order you understand that those things they are regulated by some additional documents which we have to follow too. How these documents appear? What, for instance, here is the report of one of scientific institutions, some organization. It's page number 10. Let's jump to beginning. Here is, you see. And they made report on page number 10 on their research, and that research was made, let's say, a field experiment. They placed seats to different instances. They studied the ergonomics of how it's convenient for people of these seats, and they also asked opinion of those who take part in this experiment, the participants of this experiment, and all this is explained in this report in some pages. So all those matters, they are under the close studying, you understand. After this, it's given in the view of recommendations. These recommendations we should follow too, but do remember, you may do better. You can't do worse, less than demanded by recommendations. You may do more distances, for instance. You may do your airplane more comfortable for passengers. Passengers, of course, will be quite happy because of this. But what it will be resulted in case you do greater spaces between lines, you have longer fuselage, you have more heavy structure, you have already to cry because you heard those things already dozens of times. Let's come back to that circle that we have seen. Where's that beautiful circle? Here is, you know, increase something in the area, square, and then increase it in weight, cubic. As only you increase some sizes, whether it's wing or fuselage, the overweight of airplane will be much greater in mass, in weight. And as only you increase the weight of structure, you also have to increase the weight of fuel. You need to increase, no, and so on. It's like travel by circle, closed circle, but by it's like a helic line, spiral line, and you're like walking by circle, but higher, higher, and higher each time. So better to follow the recommendations. What do I mean? Once again, remind you. Here is explanation where to hide luggage, and to pay attention, luggage hidden somewhere in nose, no, under, not far from nose, and somewhere under the rear portion of the fuselage, but not in the middle. Why? Once again, remind you, because it's low wing, yes, because through this middle it comes, they disappeared here. No, here is high wing, but idea you got, I hope. Through that place you have to pass with center wing. It's already taken with another elements. It's not the place for luggage compartment. And do pay attention to the bottom, where these things should be hidden during the flight. Quite clear where they may be hidden. Practically only in one place. There are a lot of variants actually, but when it comes about passenger airplanes, usually it's always like this. Usually it's hidden in the fuselage. And where in the fuselage? No, you see. Somewhere here it will be center wing, and additionally there will be niches for main legs of landing gear. And all this it's necessary to consider why real designing of the airplane, or at least during the preliminary laying out of this airplane. Well, and for this luggage volume, not only for the luggage weight, but for luggage volume, we also have some restrictions, some norms. Moreover, how to compose the cabin in cross section. Look, at least people should be in whole height, in full height, inside of this cabin. Of course, not so good as it's shown in this beautiful picture. It's picture provided by Airbus, you understand. Of course, in real, it's not so luxury place in the airplane for passenger. More real we have seen in another picture, like this. And even this is overesteemed, do forgive me. Actually, airplane is much more tight place, especially for the people which differ from average sizes, let's say. Here is, you see, some recommendations. So actually, it's layout of real airplane. I do not remember clearly already which one, Embraer or something like this, where I took it. And you see recommendations as to the placing or as to the sizes of seats, as to the placing of so-called hand luggage, some bags that people take into airplane passenger cabin, not passing it to the luggage compartment. About these places between lines, and so on. You see some recommendations as to cross sections. You see recommendations to pay attention for what? For the different classes and for different sizes, size between lines, at least, to pay attention, at least 66 centimeters, 660 millimeters, and so on. You might find on your own, of course, in internet. And here is what I said you that this question under these questions, whatever questions of layout of fuselage, of composing of wing, of different parameters. I said you for real designers, even while studying designers, we already see different diagrams, different plots of dependencies, how this or that parameter affect of geometry, for instance, affect to the weight, or how these or another parameters of the weight affect to the flight dynamics, or and so on. A lot of different parameters, even during preliminary design, already should be taken into consideration. Of course, for us, it's not possible now, or at least we are not going to overload you with all of this. It's the sort of brainstorm the game for you, but do remember it's payable game. It's like gambling. You have payment for this. I mean, points. In case you do it very well, you have maximum point. In case you do it somehow, you have minimum points for this, or have nothing at all. So up to you. If you need these points to your grades, you are working harder. If you don't need it, no, okay, don't do it at all. I haven't said it. Do it compulsory. So numbers of seats per row as a function of passenger number and so on. You see here is explain it. No, some explanations are in German language. Don't pay attention. Anyway, it's understandable. I do not propose you to follow to this chart. I just remind you that it comes about serious matters. Так, after you decided what is the central portion of your fuselage, what is the passenger cabin, you also need to add cockpit, and you need to add so-called aft fuselage, rear portion of the fuselage, where maybe a stabilizer fin, they also join it too, and moreover stabilizer, at least stabilizer has center wing. Do remember this. It means that if you place it to the fuselage, this aft fuselage section, it's already not usable for passengers. And moreover, for considerations of aerodynamics, do pay attention. Yeah? This place should, airplane fuselage should have some streamlined nose, and it should have some streamlined aft, like it's nearing to the end. And moreover, typically you see that airplane bottom line, it's like deviated up. What it for? Because during their takeoff and landing, airplane not in horizontal position, and if this place it's like completely cylindrical, especially if this airplane has short landing gear, may happen that while their takeoff and landing, when airplane increase angle of attack, it may happen that airplane broke the aft on the airfield. It's like fall down by this place to the airfield. So also should be accurate with this. That is checked during the landing gear designing, where to place main and nose leg. Or no, I hope we're all going to use the so-called three-wheeled scheme, typical again, conventional, and where to place this main landing gear with respect to the fuselage. It's also very important moment because in case you place it wrong while takeoff, as I'm already said you, if it will be too close to the nose, while takeoff, airplane may just kick, do forgive me, the airfield by its aft fuselage. Let's continue. Where we stopped at cockpit and aft fuselage. I propose you to watch this one, and in case you have any difficulties, do try to follow to those recommendations. Select one of them. Here is given some relative parameters, but do remember that whatever relative parameters after you follow to these recommendations, don't forget to check real sizes. and compare it with sizes of people, really. You understand that in aft fuselage, what I've been talking about, here is the place where you can't squeeze people already. And in cockpit also, what typical layout of cockpit for some airplane, in cockpit also, it should be the place where at least couple of pilots are sitting, and maybe some no something like folding seats for flight attendants, or some another person, maybe some auditor, for instance, no whatsoever. So you see, pilot, co-pilot, some place behind of them, it's also necessary, yes. And this distance between pilot and co-pilot also no less than no at least do some distance like 40 centimeters, for instance, between them, in order they may squeeze into their seats, do forgive me. And don't forget that this size from one seat to another seat, it should be inside of the fuselage, so don't make this place too much narrow in your picture. Well, and one more considerations I forgot to show you. I have prepared the pictures to show it to you, but I forgot to mention it. Sorry. Once again, let's come back to those pictures. Where to place passenger floor. Так, let's see. Passenger floor, where it should be, in the middle of the fuselage, but it means that no, we have seen the picture and we understand that person should stand in whole side, in whole size, in whole height inside, and after the person height it should be some distance, also some space. And next, it's maybe some, it's not even thickness of structure between inner skin, interior skin, and the outer skin. It would be no less than 15 centimeters, actually. Because there we have structural elements, there we have electrical wires, we have some systems, we have noise and heat protection materials inside, between interior skin and outer skin. Not so directly like designed, like we have measured the person, applied the height of person to the middle line of the airplane, and we already have it. No. Line of flow usually is lower than horizontal plane of airplane, what is middle plane of airplane, like middle of the cylinder. Normally, even in one decked, no single decked airplane, we might see that these lines, they are lower than line of the floor. Whatever design layout we're watching, it's visible. How much lower? Look, it's also under recommendations, approximately like this. But again, it depends on what shape of fuselage you are going to use. No, at least don't forget about that line is a bit lower, line of flow, of passenger flow. It's lower than the line of center fuselage. Distance from floor to the top of fuselage should be enough to accommodate person. Where this person in the picture? You see? Так. And next, additionally, we have some space here, as I already said you, altogether it's around 15, no, in average, 10, 15 centimeters. After this, we may see what is approximately diameter of the fuselage. Of course, it's very complicated task, at least it seems like, for the first time. So in case you have no real difficulties to understand it, or you can't stand this task at all, no, do check again the prototype and try to follow to the prototype. But I'm afraid prototypes may be very different one from another. It may happen. And in this case, do use your own brains, please, but follow to those recommendations. Well, after fuselage has been designed already, what is next? Oh, people, do forgive me. I need to watch time again. I'm writing preliminary what time we should finish to. Yes, I have more than half an hour yet. Now, after we have designed it already, no, at least we think that we have designed the fuselage, it's a turn to design, to think about engines. Not to design engines. Engines we are only selecting. I hope you do remember. And in this term, you already educated enough to understand how to find engine which correspond to your range of speed. Approximately, no, let's agree, like zero point 0.6, it's turboprop yet? Maybe. 0.6, 0.8, it's turbofan, maybe, of different bypass ratio. And what is higher than 0.8, it's already clean turbojet. If we agree at least to these values, you need to understand what kind of engine you are searching for. Let's place engines. We already talked about today that variance of today in previous video. I mean, for me it's still today, and for you, I don't know, not sure. Variance of placing of engines, even for passenger airplane of the same class, I mean approximately the same distance, the same amount of people inside of of flight deck. Variance more than enough. The most typical variants are under the wing, and at the aft fuselage. The most popular now in Western companies, as much as I see, it's not the whole complete truth. It's not like the truth divine, what I say right now. So you may analyze on your own. The most typical by now it's placing the engines under the wing. Why I say the most typical? Because you understand we have the couple of more famous competitors, let's say in Western countries, Airbus and Boeing, and their airplanes somehow similar in technical decisions. They are different. They even visually different. If we compare Boeing and Airbus of the same class, of the same capacity, we will see that Airbus airplane is like more fat, more clumsy, I would say. It's not so slim, not so streamlined. And no, once again, it depends on traditions of design also. Besides of all another factors, it depends on commonality, let's say, of design, like its inheritance in design. It's too much difficult to design new airplane from zero, let's say, and usually it's like redesigning, perfecting, changing of previous airplanes to another amount of passenger seats, for instance, or to another mm, level of comfortability, so on. And that is why it's like inherit inner structure of previous airplanes, inherit the general appearance of previous airplanes. And if you remember, I have shown you that Boeing been trying to create completely new concept of airplane, of passenger airplane, of huge airliner. But finally, they came back to the usual conventional scheme of airliner, just of greater sizes, let's say, like 3 decks, for instance, but still the same conventional design. No, because this design also it's limited not only by demands of aerodynamics, weight, strength, even manufacturing. It's also limited by demands of maintenance. If this airplane completely new, very different, like flying wing, for instance. Do imagine the airplane of scheme flying wing, which supported with landing gear somewhere, no, on sides. of this landing of this flying wing. What is the width of runway it may use first? Second, whether it's able to land somewhere in the middle size cities, let's say middle-sized cities, or it's suited only for megapolises, for airplanes which belong to megapolises, let's say. Where it will be usable, what type of infrastructure it's need. For instance, hangars for such airplanes will be completely different, and so on. So sharp changing, like revolutionary changing of the general appearance of airplane will be resulted in practically technical disaster, technical reconsidering of everything, starting from manufacturing and finishing with maintenance, with all the structure of airports. Let's say when airports been transferred from prop airliners to jet airliners, it was like revolutions in design of airports themselves, in the lengths of runway, in the amount of additional substructures inside, sub infrastructure in airports. In case you study such histories, let's say someone's stories, maybe, or even some, how it's called, belletristics. Uh, in case you read something like this, you may imagine, you may understand that you will be surprised that we not even think about like this, how much the changing in design of technical devices. Next, it's reflected in the life of the whole cities, let's say, because airplanes at least should be taken away from cities by demands of noise. No, a lot of different things. Right now, let's continue about our story about engines. Once again, if you place engines to the wing, it's necessary also to remember that in this case, wing will be closer to the nose. Yes, seems like it's better. But if you have low wing, do forgive me, I have found on internet this picture, and I think it's some idiotic mistake. I left it on purpose. That one I reflected, no, flip it on the in another program. Да? Why I think it's mistake? Do pay attention. What do it on purpose? I left it. Normally, all the passenger doors, all the passenger openings in the fuselage, they are on the left board normally. Right board, it's for maybe for crew, maybe for luggage, maybe for emergency exits. By the word, emergency exits. Amount of emergency exits also restricted, demanded by international norms. Так, that one we will delete because I think it's wrong. After you have seen it, that one it's maybe someone flip it also the picture occasionally. Suppose it to be like this normally. But to pay attention now, engines under the wing. It's low wing and engines under the wing. And now do imagine what it will be resulted in. Fan engine, fan jet, fan bypass engine, turbofan. Oh, I've recollected correct name in English. Turbofan engine, and this turbofan engine, what it differ from normal one, from the usual turbojet? Diameter, size of engine much greater than size of turbojet. No, not directly. We have seen it in one of classes that in case we calculated the area of circles, we understand that amount, this additional area, additional volume that pass through the secondary channel, it's not directly increased diameter of engine twice. So bypass ratio, on one hand, of course, it will be higher bypass ratio will be resulted in increasing of diameter, but depending on the aerodynamical perfection of the fan itself and of inner ducts, it's also not quite directly depends on size of inner engine. And whatsoever turbofan is wider in diameter. Now let's see what it may be resulted in. Oh, to forgive me, it's my notebook that I hold in hands with notes in order to remember not forget something to say to you and to watch time additionally. Um, I will try to show you what it may be resulted in on example of Boeing, if I'm not mistaken, Boeing Dreamliner, Boeing Dreamliner. Engines under the wing practically scratching front view. Scratching the airfield. Do you imagine this? They are of great diameter and under the wing they are practically already touching the airfield. Not Dreamliner, Dreamliner not. No, here is a cylindrical one. 737. Oh, yes, 737. Look into this honest face. That is quite the situation that I said about. We even copy it for you, maybe, if possible. No, sorry, switch it on. I'm really blind. Ha. Okay. If you behave like this, we will behave like that. Now it's work. You see what happened to engine nacelles? Because those engines under the wing and because size of engine is too huge, too big in order to be placed on this place under the wing. Of course, it's possible to recalculate those inner ducts and so on, but whatsoever, do imagine inside the fan, and fan may be only circular, it's cylinder. No, this shaft with blades, no, you've seen it. It's practically the same prop, but with a great amount of blades. And quite clear, this intake, its shape of intake only changed, but inside it will be fan, which should be of the same diameter as it should be. Yeah, you can't change a fan to something like half elliptical or triangular. You understand it? So placing the engine under the wing have it limit. What may be done in case you understand, no, what in real design, in case you understand that your engine is too big and you can't squeeze it under the wing because it's really already a bit touching the field. The higher from airfield, the better you understand it because while takeoff, landing, while runway and taxi drive, so call it when it's just travel between different elements of the airport. Airplane may suck the dust, some little stones, some pieces of trash, some garbage inside the engine, and engine will be half spoiled in this case. And of course, there are some protective devices there, so on, but better to remember about simple rules. The far from airfield, the better. Of course, what is the reason for placing no, in such improper position of engines? I'm already said. Of course, it's resulted in unloading the wing in flight. On ground, it's additionally pull uh, wings to the ground. No, it's like heavier wing, seems like. But in flight, when you are loaded up, in contrary, engine create counter moment engine on the wing and help you to unload the wing. And due to this, the whole weight of the wing, the whole weight of structure of wing, more probably it may be less than when engine or some another element of structure is not present here. If engine, you have selected some engine, it should be coupled according to the rules, no less than two on passenger airplane, no less than two, but you may do more engines. You may select couple of less sized engines with less thrust. Altogether, four engines may create your necessary thrust, but in this case, also you need to remember that general weight of four engines with their nacelles, pylons, control systems, it will be a bit heavier than two engines. So it's also not ideal decision. No, as I already said you, there is no best decision. In aircraft design, no one, the only best decision. It's dozens of decisions and each of them has advantages and disadvantages. One more variant of engine placing, no, like more popular, да? One popular variant, it's absent here. Oh, great. Sorry. No, at least I have shown you that way, where you may place engines in case we're talking about passenger airplane. Engines may be placed immediately to the fuselage. To the fuselage at the end, like aft fuselage, or even inside of the fin. Let's see once again couple of examples. What do we have here? Here we may already, we don't need it any longer. I hope we may sacrifice it. Well, Tupolev airplane, I certainly do remember. And some of Brazilian airplanes, at least, also they use this scheme. You see engines on pylons by sides of the fuselage. No, if I try to increase it, it's disappear. Oh, great. We don't need such a happiness. Do try to ask airplane. Oh, passenger jet. Better to type passenger jet, I trust. Passenger jet. It would better understand us. With engines on fuselage. Some Brazilian airplanes fuselage use this scheme. Так, airline spotter. By the word, it comes about two different airplanes, certainly. Look, here is very similar, agree? Practical is the same, like the same family, but do pay attention what is the difference. Here is we have turbofan engine. It's visible for you, I hope. And here we have just simple turbojet engine. I'm not sure that this resource is available for me, do forgive me. Let's check, because in our country also we have some restrictions for this. No, it seems like it's some educating resource or something like this. And whether this picture is, it's Embraer, you see, no? Embraer and engines on their fuselage, on pylons. And to pay attention, engines are higher than the wing, and stabilizer in this case, of course, it's not placeable immediately behind of engines. Yes, stabilizers already of T-shaped scheme. Stabilizer is on the fin, on the top of the fin. What extremely interested to understand what is here, why they are different. Look, they compare to different companies engines, do forgive me, airplanes. Airplanes are extremely similar, no, practically like one to one, you see. But one of them is American one. Bombardier it's American company, and Embraer it's Brazilian company, if I'm not mistaken. I trust I'm not, but who knows? Maybe I lose my mind a couple of minutes ago. Let me to show you here also why I save it in this set of photos, because actually the set of photos is for passing to you, like to help you, you understand. What? And what we might say, no, we may of course check, no problem. We see the names of this airplane, and it's very simple to check my words. What I think is the difference, look like twin brothers at all. What is the difference? Do forgive me this laugh, but pay attention where turbofan engine is used. On Mach numbers, no, as we agreed, 0. 0.6, 0.7, no, let it be 0.8, but not higher. Higher, you have something what is uh, turbojet with afterburn, not for passengers, of course, no any afterburning for passengers airplane, you understand. And here is practically these twin brothers, a little bit differ, pay attention by area of fin, no, with respect to general sizes of them, a bit different amount, no, area for fin here. Almost the same. Here is wingtips in Bombardier. No, Bombardier, it's already use this winglets. It's a standard for them at all, without any discussion. What is the difference? I think Bombardier, this plane, it's a bit slower. It's fly with another speed. I think Embraer, this airplane, fly with a bit higher speed. And how it's reflected in their general appearance. I already said they practically of the same appearance, but look at the nose. This one, it's a bit longer. You see, it's like a bit pulled front. All another proportions practically identical. Besides of these illuminators, amount of doors, pay attention. Here is 2 emergency exits immediately to the wing. By the word, as I said, yes, that during the belly landing, in case of belly landing, this wing under the fuselage, it's like one more protective device for the passenger cabin, and additionally, it may save somehow the time, increase the time for passenger evacuation from cabin, and may help also passengers to leave airplane safely, for instance, to jump to the wing and from wing already to to the ground. While another emergency exit, they have additional devices for evacuating the people. You do remember, I hope. Maybe you've seen it in movies, so somehow. Let's check. What just let's say for fun. Do we have time for such a fun? I hope yes. Uh, Bombardier CR jet. Bombardier. Bomb. Is it English? Bombardier. CR jet. Flight performances. Thanks. And oi oi oi. I should have done it first. The copy to typeless. Bombardier CR jet flight performances, and it's proposed to follow. Note here is Sky Library Aviation Safety. Not sure. It's working. Working. Yes, it's available. Happy me. And one more. It was Embraer E. Arjet. Embraer. E. Arjet. Flight performances. To propose, maybe find the same resource for it. Seems like not. No, Wikipedia and Embraer itself. Why? Go to the home page. Thank you. Evil people. We don't need it. Let's try to. Oh, here is maybe. No, it said that a family of airplanes. No, let's take a look into Wikipedia for this. Technical characteristic in Wikipedia usually given and operational history. Oh, specification. Here is. And for that one, I have an idea that that one is not so speedy with respect to the first one. Cruise. Mach number 08. Here is, no, at least as it given in this beautiful picture. It's that low speedy, no, comparatively to low speedy because it has fan engine. Maybe they are practically the same speed variant. Thank you. What about speed? Fuel capacity, maximum payload. Oh, here is. No, you see, practically the same. Here it's even said that 078. No, maybe it's because we do not understand what is real name of the airplane because they are very close. You see, there are three variants here already, yes, and they are also maybe it's necessary to check in another resources what they say about this regional CRJ 90. But general idea is turbojet for higher speed, turbofans for less speed, but turbofan help you to save fuel. Turbojet is like more greedy engine. It takes more fuel. It has higher fuel consumption ratio. And that one is more economic variant. But of course, this one it's more difficult to place in geometry of the airplane. And in general, you see similar purposes, similar capacity, let's say, maybe sizes may be different by the word, because you see illuminators here. I'm not even talking about amount of illuminators, but illuminators sizes, window sizes, a little bit different with respect to the diameter of the fuselage. If we may check it, that one is wing, body, narrow wingspan, power plant. That's great. Diameter I'm not see. Takeoff. Okay, maximum takeoff weight here is 36. It's for Z1, which with fan engine, and maximum takeoff weight here. Z1 is less in takeoff weight, in case I understand correctly. That is 20,000. It means around 30% to carry. Да, вот смотрите, look at this. Different variants, you see? Different variants of this airplane, number of people to be carried. And here is no way it's written. Охохонюшки. I'm not see. Okay, maybe you will found it, but not now. Yes, and when you found it, we may continue. I was said that Serjet family, by the word, look, it's Serjet family also. It's not one airplane. It's Serjet 900 we have found. But here is the whole family of them, and they're a bit different. Well, I was said that we at the end of our classes we may have a couple of classes real online. It means that both me and you will be present in that class. No, how to search information, how to analyze information. I hope you already understood. Above the all, I propose you to follow to prototypes, of course, because it's your very first time. No, I think it's your very first time. Maybe you already did similar tasks in your university. Who knows? I don't know. Because really, you are not first years, as I had understood from explanations of our people. And what should be the final result of your task? No, besides of some explanatory note that uh, give me some explanation how you did it, like table with airplanes to be considered the prototypes, some tracks of your decisions, like it was in my example, да? That after analyzing the, you don't need all these pictures to insert, you understand, I hope, да? That all these beautiful pictures, they to explain you something, but not to be copied to your reports, sorry. uh, Something like this, you see, after here supposed to be table with filled information, where you have no information, of course, placing this empty place, like, you know, nothing is here. But when it comes about real data, when it comes about uh, relative weights, please recalculate them. When it comes about real geometry, you may do two different tables, like one is for masses and other for geometry. Again, all information you have found for geometry of your airplane in one group of columns. Feel it, not feel it, depending on what you have found really. Don't invent statistical data. What? And next, you need also to recalculate some additional values, like wing aspect ratio for wing, for instance, wing taper ratio in case it's swept wing, not straight one. Uh, Also, if I were you, I would do the same, at least for the stabilizer and fin. No, if I were you. Whether it's really necessary or not for you, you will decide. And once again, remind you that your task is up to 25 points. In case it's like quarter of your semester grade. In case you do everything, no, not good or ideally, I would say, but laborious. In case I say you've been working. And no, I hope you do it well, because as far as I know, Chinese students very responsible. I have some years of Chinese students here in Hai, and I've seen that really responsible, laborious, efficient, and so on. Uh, a lot of good things may say about those students that I have already seen. I don't know what about you. I hope you are not worse than previous ones. And next, you need to finally said me what is the weight of airplane, takeoff weight of zero iteration, what is the area of the wing, and what consideration you have been used. Either it was a specific payload to the wing. No, I recommend you to try both of variants and to select greater one, to select the one which correspond to your prototypes by specific loads. As you have seen, да? The gross weight of airplane, maximum takeoff weight, divided onto area of the wing. Do compare these parameters in the table with relative parameters, as I said. Next is calculating of wing parameters like span and chord, having area and some dimensionless parameters. You may do it. The same, if you not mind, please do for the stabilizer, the and fin. Stabilizer and fin area you may not calculate because it's too complicated, and moreover, it's necessary to understand the distance between wing and stabilizer. At least for this, it's necessary to join it, to place it somewhere, to accommodate them somewhere on the fuselage. And first, it seems it's necessary to design the fuselage in this case. So let's take area of them like 20%, for instance. But next, you need to recalculate their span and chord. After all your calculation, I recommend to refer to prototype. In case you did something completely wrong, comparing to the prototype, you will notice this. And next, you goes into fuselage design, which depends on amount of people you need to accommodate inside, and some another additional factors like how many people, how many toilets they need, how many kitchens, what is the cockpit, and so on and so forth. Of course, I do not propose you to calculate it exactly, but at least don't forget about it. When you calculating the length of the fuselage, please refer to some pictures that I placed here, and no, I shown you where I took them from, and those books I also will send you to help you to make decisions. And finally, you need to decide where to place landing gear. Now, in case you have passenger airplane, you all have passenger airplane of conventional scheme, I hope. I recommend you to hide it inside of the fuselage. In case you have low wing, it's also possible to hide it inside of wing itself, and it means that you may place distance between legs wider. In the most, let's say, interesting variants, airplanes even have special nacelles on the wing to hide the engine. For instance, on some wings, it's visible. No, right now, I will not search for it in our slides. It was visible like somewhere into the engine nacelle. It's additional place added to hide landing gear. Somewhere it was some nacelle between flaps in order to hide landing gear there. No, I don't think that you need to invent some divertive schemes of landing gear hiding, retracting. Actually, it should be said retracting of landing gear. For this very first approximation, if I were you, I would hide the landing gear main legs into the fuselage under the bottom and nose quite clear under the cockpit. Exit door for passengers. No, to pay attention. Typically, we get used to see them, those doors, somewhere not far from nose. But in some airplanes, especially in little ones, which are for 30 passengers, for 50 passengers, you may meet such decision. Look, passenger door, it's at the rear fuselage, closer to the tail unit. And to pay attention, it's even inbuilt door, as you might see. And it's a piece of fuselage that it's like fall down to the ground, and it serves as a staircase to the fuselage. Quite clear that that variant is possible when you have short landing gear. When you have short landing gear, when you have engines far from airfield due to using of high wing, you may afford this. You may place, you may not use additional airfield devices, airport devices for placing people on board and evacuating people from airplane. No, I'm not talking about emergency situation. You understand? In case you have low wing, in case you have big sizes of airplane, low wing and engines under the wing, it means that you need to move fuselage higher from the airfield. And in this case, of course, this variant already doesn't work. And also, it's necessary when you're analyzing statistical data, it's necessary to consider what type of airfield this airplane is purposed for. Some airplanes, especially when it comes about not big airplanes, not airliners, they may be either for no, civilized airports, let's say, with concrete runway, with runway which is very hard. And in other airplanes, they are proposed for less civilized conditions, for ground airfield or no, for some not high class of airfield, let's say. And due to this, they have no, another approach to design, what this placing the engines as far as possible from the airfield. It's typical for the airplanes which working in the not high class airports, like somewhere maybe in little city, in village, wherever, and ground airfield. When it comes about airliners, which are too heavy to be used in, no, too heavy and too big to be used in non-civilized places, let's say, or less civilized places. No, of course, it's already another approach even to design, as you understand. So engines up to you, but do forgive me when you placing the engines. Don't forget that placing engines to the fuselage, it's increasing the length of fuselage, because besides of joining the stabilizer, the fin here, you also need to have inner structure to join pylons of engines here between each other, because you have couple of engines, for instance, here, or even four engines. So you need to increase a bit diameter, to forgive me, the length of the fuselage in this place, like this portion of the fuselage. No fuel, as we agreed, I hope, we are going to place inside of the wing and maybe inside of the fin. To be frank, it's necessary also to calculate, no, in real life, to calculate inner volumes of them, considering their sizes, considering the thicknesses, relative thicknesses of profiles that you have been selected. And maybe it's necessary to increase whether the area of the wing in order to increase volume for the fuel, or area of fin, or maybe length of the fuselage. But in real life, I mean, for long range airplanes, the storage, the fuel tank, storage for fuel, it might be should be also calculated, and you need to understand where to hide this fuel during the flight. Bottom is, as we already talked, for luggage, for different devices, for hiding the landing gear. Very well. Так, what about time? And because I need to explain your variance. Now, finally, you are finishing with drawing, and drawing of general view, once again show you. Once I have already explained it somewhere, not in the even in the practical class, but I do remember I talked about this already. Drawing of general view shows three cross sections. These maybe when we talked about flight controls, about main aggregates, three cross section. Oh my, maybe I'm already too tired today to talk. Three projections, and these three projections on the main view, do pay attention, there are different airplanes. But it's not visible, of course, in this picture, but they are completely different. This little one, it's around 100 of passenger, and what you see on the right side, it's actually Boeing 747. But do compare if we see them in equal size, no, like they are scaled, and we do not understand their real sizes. They are too much similar. In case you not prepared, let's say, to analyze their proportion, it's the same airplane, but certainly it's visible that it's not the same airplane. But general proportions are very similar, you see. Decisions as to the wing sweepness, as to the wing shape, positioning of the wing, approximately proportionally very similar. It doesn't mean that one group of designer has copied another group of designer. It means that these designer follow to the same physical, aerodynamical, and so on principles. You understand it, I hope. Well, main view. Airplane left board is visible, and like airplane fly to the edge, to the left edge of drawing in this direction. Actually, it's shown in ground position, as you might see. But if in case it's so-called three legged wheel with rear wheel, it's also shown in horizontal position, in flight position. For this airplane, flight position and airfield position, they coincide. For airplanes like, wait a second, one more additional window, airplane with airplane with rear leg. Oh, what happened? No, something like this. Those, no, very funny. Wisteria relax, you see? It's proposed now. Oh, here is. Da. If we're talking about such airplane, in drawing, it's also will be visible in horizontal position, like in cruise flight, compulsory. No, according to the rules of drawings, and these rules are practically the same in different countries. So left board in the main view, in flight position. Next, top view, top projection, you see. The top of airplane visible in all the drawings that we might see here. It's a top of airplane, and view, which usually we call left view, it's visible the front view of airplane, the front face, let's say, of airplane. And there are some typical sizes that's supposed to be shown in the general view of airplane. Overall sizes above the all, general lengths. In each drawing that you might see, you will find it. It's in different projection, but you might find it. The span of the wing, the span of stabilizer here, additionally to pay attention. In all the drawings, compulsory given span of the wing, span of stabilizer. Compulsory sizes of fuselage, like overall size of airplane, its overall size not compulsory for fuselage, because what but for instance, look at this. For Antonov 72, overall size of the airplane, it's from nose of airplane to the rear edge of fin at the top, you see. But size of fuselage is a bit less. No, typically size of fuselage is also shown. Not compulsory, maybe for you. If you not mind, you may show it. And what else? The distance between engines, and for landing gear, we show again the distance between them, the base of landing gear, it's called. And here is, do forgive me, forgot the word. No, the distance between left and right legs of three-wheeled landing gear. Forgot the correct words. Too tired maybe today. In English, I will find this word and send it with you to you, this word. And one more thing I need to remind you, how to identify what you need to design. So I hope you understood. I wait for you not only some text of explanation, 10 points maximum in case you do everything correct, but I wait you to make such a picture. I don't think that you need to use some complex systems for drawings. Some, if you possess skills of drawing in some two-dimensional systems, please do it in two-dimensional system if it's convenient for you. If it's some difficulty for you, I will accept even no accurate one, accurate sketch drawn by hand, no, by using, of course, some instruments, some tools like rulers, for instance. It should be accurate. It should be more similar to the drawing than to the childish do. You understand it? And in this drawing, please follow to the rules of scale. No, like everything should be in proportions. No, like real drawing. So those who will do the general view of airplane, the general view drawing of airplane, and if it's not completely ugly, I mean it's made accurately, 25 points are yours. Your variant, once again, let's come back to the story about variants. I place it's already to the file at the end, and of course I'll send it to you in the talk, and in open I will open the talk right now to remind you what you have already seen. In our university, you've been placed into groups, all 126 person. Why it doesn't work? It's working. And I have compared our Ukrainian document with document bill given by your university. Here you see your names in Chinese and English, and also you see I found you what group you are. You see this list of your university rearranged by groups. One group, there are three yellow group and three green groups. Why it's like this? Because you have different specialization actually in those groups. Yellow groups, as far as I understand, maybe they will be specialized in design, aerodynamics, something like this. And as far as I understand, maybe I'm wrong, the groups that I have colored as green groups, they are specialized in manufacturing next, because next they come to me to another discipline about manufacturing. Maybe I'm wrong about this. I don't know. But at least I see you as 6 different groups in our documents. And in such a list of group in our documents, each of you, no, because we use another alphabet, you understand, each of you has number. No, for instance, here is an, if I pronounce wrong, do forgive me. Так, let's see. Наказ. It's a group. Oi, it's a group number 2. Here is An Xiaokai. It's written in our language. No, sorry if I pronounce wrong. This person, whether it's gentleman or lady, difficult to understand for me right now. Also, you understand, I'm not get used to your names. For instance, somewhere I've met Rui, and I understand maybe it's a lady, just because I have got such a student, lady student, Rui, some years ago. But maybe this name is usable for different situations, for different sexes, for boys and for girls. Shuai, I've seen. Shuai, I have boy once. Там Hunzin, it was a boy in one of my groups. When I met students immediately offline, as it's called. It was even before COVID. Next, each of you has number in such a list, as you might see. No? And that is why I'm going to use these numbers when given the variance for you. What these variants are, you already see. Of course, they are rather similar, I should say. not much difference between 50 passenger, 80 passenger. When you start analyze statistical data, more probably you will see that internet show you practically the same airplanes, or at least the airplanes of the same family, which very close to each other in parameters, like we have seen just some minutes ago on Embraer airplane, for instance. The whole family, 5 or 7 airplanes, which vary literally with 10 people, or vary with range for 500 kilometers, for instance. So red line is amount of passenger in your airplane. What, for instance, once again, what Gao Jumbo, да, number 5, group number 102, you see, number 5. And this person, number 5, oh, here is, this person should have uh, 50 passenger, range 7,000 kilometers. What, here is the number of group, number of person in this group, and you see variance. Let's take someone else in green group. Group 1, no, let it be third group. Вот. Gao E, maybe, да? Gao E, and do forgive me if I pronounce not correct. Once again, and what do we see? This person is number 7. Do find his group. Here is his group. Do find number 7 here. And what do we see? 80 people, 6,000 kilometers. And additionally, not compulsory really, but additionally, I think that if possible, do find airplanes for that or another speed range. Additionally, I added here like Mach number. No, like we have seen them, for instance, number 5 here and Mach number 08. Number 5 in another group, it will have another amount of passenger, another range, and another Mach number. 126 person, how to supply you with different variants? You understand, it's practically unbearable task. There are no such variety of coincidence of capacity of payload, да, and of range. So some of these demands, let's say, for statistical data, no, they are artificial, you understand. And in case you're not able to find something exactly correspond to your variant, I mean, in prototypes, then use your brains, please. In terms of what? For instance, you see prototypes of appropriate amount of people, but range is not exactly yours. Range of airplanes that you need to design is greater than you have found in prototypes. What does it mean for you? Let's use brains. It means that you need to increase the relative weight of the fuel for respect, no, for the account of what you may reduce. Crew probably not reducible. There is nothing to reduce there, you understand. Maybe you may vary a bit with relative weight of payload and relative weight of empty airplane. Empty, it means structure, equipment, engine weight. No, we've seen it in explanation. Or in contrary, if you see that you have airplanes, prototypes of appropriate range, but amount of people a little bit vary, less or more than you need. It's the same decision. It means that in order to design your very own, you need to increase relative weight of payload and reduce another relative weights respectively. No, except of the weight of crew, of course. Crew, no, actually, crew you may count absolute weight since beginning. No, depending on how many you understand, you have people pilot and co-pilot, and depending how many people you have in passenger cabin, you have that or another amount of flight attendants, flight stewards. I hope with your variance it's clear. I hope, I trust not hope, I trust you will stand it and pass it successfully. And what is next? What I promised to you? No, how promise in quotes. Uh, it will be no more such complex tasks. That is the most difficult one. You will have one more task for grade. It will be the only one, and it will be already a task about manufacturing. And I promise it will be not so difficult. That is the most difficult. No, that is the most expensive. Certainly. If you already did the first one, the first and second one, which 5 point and 5 point, it was nothing at all. You understand? No? It was necessary to give short characteristic like 7, 12 words that you know about airplane, whether it's biplane, triplane, or monoplane, cantilever or strutted, low wing, high wing, no, and so on. Characterize a plane by some words. It's nothing to do at all. You understand? And when it comes about second task, practical is the same. The only difficulty that you need to add some labels, let's say, to that photo in order I may understand what you mean. Where here is the aileron, where the flap you see, stabilizer, wing, and so on and so forth for aggregates of the airplane. When it comes about this one, about this task, it's extremely creative task. But as I'm already said you, all the students of our faculty, year by year, 10 by 10 of years, I would say, pass through the same task. Difficult, not difficult, but we started since the first year in order to get used to those tasks and in order to study at least technique, general approach to airplane design. Well, what about time? I'm afraid time is. I hope I'm not overtime it again, but right now I can't say. It's necessary to check. Let's stop record on this. Wish you luck with this task, and I hope you will show very good results.